Alright, so today we're going to take a break from geometry a little bit. We're going to review how to solve quadratic equations just in case it creeps up here in a section or two. We'll see. Anyway, we'll get talk about that later. But, so solving quadratic equations is something you would have spent probably a month or maybe more last year in Algebra 1. So first of all, we have to know how to recognize a quadratic equation because you solve quadratic equations differently than linear equations. So a quadratic equation is going to be in the form ax squared plus bx plus c, where a does not equal 0. The big thing that you are going to see in a quadratic equation is going to have an x squared. It has to have an x squared. It doesn't have to have the bx, it doesn't have to have the c, but it has to have the x squared. That's why it says a cannot be 0, because if a is 0, it would be 0x squared, which would have no x squared. Okay? So it has to have the x squared. Now, in Algebra 1, you probably learned 4 or 5 ways to solve a quadratic equation. So you first would have learned how to solve by graphing, which is super incredibly fun, and then by the square root method, and then by factoring, and then completing the square, and then the quadratic formula. So fun. Okay? We're not going to go through all 5 of those today. We do not have time. Really, if you look at all of those methods, probably the one that works most of the time and is the simplest is factoring. Works most of the time and is simplest to solve by factoring. And then if you can't solve it by factoring, you can solve any quadratic equation by the quadratic formula. So we're just going to focus on those 2 today. So starting off with factoring, what we're probably going to do today is we're going to see if we can solve it by factoring. If we can solve it by factoring, we're going to go that route. If we can't solve it by factoring, we're just going to jump to the quadratic formula. So if you're going to solve it by factoring, you're going to use the zero product property, which says if a times b equals 0, then either a equals 0 or b equals 0. It just means if I tell you I multiply these 2 things together and I got 0, one of those 2 things has to be 0. There's no other possible way to multiply and get 0 if one of those things wasn't 0. So you're going to factor, set it equal to 0, factor, set each factor equal to 0, and then solve. If you can't do that, then you're going to do the quadratic formula. So as a reminder, what the quadratic formula is, it says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you take the a, b, and c from your equation, plug them in, simplify, and it just gives you your answer. So it takes a little bit more time than factoring, but it does work for any quadratic equation. So let's start with this first one here. If I have x squared plus 9x plus 20, what we're probably going to do first today is try to solve it by factoring. So if you're going to solve it by factoring, use the zero product property. So the first part in that, it has to be set equal to 0, which this one is. Okay? It doesn't work if it's something times something equals 5, or something times something equals 10. It only works if it says something times something equals 0. So the first thing you have to do is set it equal to 0, which is already done for us. But the next thing, it needs to be a product. It needs to say something times something equals 0. So I need to take this, and I need to factor it. Because that's exactly what factoring does. Factoring produces a product. Now, we reviewed factoring for like a day before the state assessments. So as a reminder how factoring works, it's the opposite of FOILing. So I'm trying to figure out what would I FOIL out to give me that back. I definitely at least try to factor if my f is an x squared. Because I already know how to get x squared. What times what gives me x squared? Okay, it has to be x times x. We already know that. So if it's an x squared, I'm for sure going to at least try to factor. Okay? Now, to figure out the rest of this, remember that if I were to FOIL this out, my L, these last terms multiplied together gives me 20. But also, when you FOIL it out, you do the F, O, I, and then the L, the O, and I. Remember? I combined them together. I added So you're looking for the numbers that multiply to give you 20, but add to give you 9. 5 and 4. So x plus 5, x plus 4. If you were to FOIL that out, you would get x squared plus 9x plus 20 back. Now what I have something times something equals 0. The only possible way I can multiply this by this, one of those has to be 0. Either x plus 5 would have to be 0. Because think about it. If that is 0, 0 times whatever x plus 4 ends up being, doesn't matter what it is, because 0 times anything gives you 0. That would work. Or x plus 4 would have to be 0. Because once again, if you take x plus 5, whatever that ends up being, times 0, it gives you 0. That would work as well. So you set each factor equal to 0, and you solve. Subtract 5, you get x equals negative 5. Subtract 4, x would equal negative 4. So to solve by factoring, set it equal to 0, factor, set each factor equal to 0. Now, sometimes we either can't use factoring because there are some polynomials that just can't be factored. There's no possible way to factor them. Or there's some that maybe we just don't want to factor because they're difficult to factor. So like this one, what I look for, if it's an x squared and just an x squared, I'm going to at least try to factor it. If it's like a 7x squared or a 10x squared or a 5x squared, I usually don't even bother with factoring. You may be able to factor it, but those ones take a little bit more time to factor. You have to do the airplane method, you can guess and check, you can do the factor by grouping. They take a little bit more time, and maybe you go through that entire process and it turns out you can't factor them. You got to do the quadratic formula anyway. So for me, if I see that it's a 7x squared, a 10x squared, a 5x, if there's a number in front of the x squared, I'm just going to jump to the quadratic formula. Now for the quadratic formula, like factoring, it has to be set equal to 0. Once it's set equal to 0, you can identify your a, b, and c that you're going to use to plug into your formula. So remember, these are in the form a x squared, so a is 7, plus bx, so b is 6, plus c, be careful with the signs, my c is going to be negative 1. So what you're going to do with these three numbers, you're going to plug them into your quadratic formula, which says x equals, the first thing I'm going to do is I'm going to take the opposite of b. So if b is 6, I'm going to plug in negative 6. Plus or minus the square root. Under the radical, it says b squared minus 4ac. So I'm first going to take b squared, so 6 squared, minus 4 times a, which is 7, times c, which is negative 1, all over 2 times a, which is 7. Okay, so you have to make sure you plug the numbers in correctly, but this first step in simplifying is the most important one. This is where most of the mistakes occur. So in this first step of simplifying, we're going to leave the negative 6 plus or minus. I can't do anything with that, so we're going to leave it the same. Now, underneath the radical, there's two things you can do. You can take b squared. So you can take 6 squared, which is 36. But in order of operations, the next thing that I would do would be to multiply, right? Because I have exponents, subtraction, and multiplication. The multiplication would come next. This right here is where like 97% of the mistakes are made with the quadratic formula. This step right here. Because if you're going to do the multiplication, you have to figure out what sign, whether this number, when you multiply them, if it's going to be positive or negative. And that tiny little step right there is where most of the mistakes are made with the quadratic formula. Because here's what happens. You are multiplying minus 4. It's always going to be a minus 4. It's always going to be a negative 4 because that's the formula. B squared minus 4ac. But you're going to take a negative 4 times a times c. In this case, negative 4 times a positive 7 times a negative 1. And you see those two negatives? What happens when you multiply two negatives together? You get a positive. That sign right there is where I would almost have 97% of the mistakes remember the quadratic formula. So take an extra second, make sure you get that sign right. And then you would take 4 times 7 times 1, which is 28, all over 2 times 7 is 14. Now, once you get to this step, you kind of start to see the light at the end of the tunnel. I could add these together. 36 plus 28 gives me 64. So under my radical, I have 64. I can take the square root of 64, right? The square root of 64 is 8. So I now have negative 6 plus or minus 8 over 14. And now you're going to have two answers. The first answer is negative 6 plus 8, which is 2. Divide that by 14. Don't write this as a decimal, just reduce it as a fraction. You get 1/7. The second answer is going to be negative 6 minus 8, which is negative 14 over 14 would be negative 1. So your answers are 1/7 and negative 1. Okay, let's get this glued in. It should be... Okay, so 7, 1 was 67, so this is 69. This is solving quadratic equations review. All right, so when we get to your homework today, the directions in your homework say something along the lines of solve for irrational answers. Write your answer in simplest form and round to the nearest hundredth. I just want you guys to round. Now, how you're going to know if it is an irrational answer. The last two problems that we did, the two on the left-hand side, both of these are what is called a rational answer. If it's rational, you can give an exact, perfect answer as either a fraction or a decimal. Okay? If you can factor it, it's rational. It's always rational. It doesn't matter if it's a fraction or decimal. It's always, if you can factor it, it's rational. If you have to do the quadratic formula, on this one, the number under the radical, I got the square root of 64, and you can take the square root of 64, it's 8. That's always going to be a rational answer. How you know it would be irrational is if you got, like, the square root of 10. You can't take the square root of 10, right? That's not an exact answer. If under the radical you get a not perfect square number, it is irrational, which is where you know you're going to have to round. So we'll see a couple of those. But let's start with this first one. It says x squared minus 3x minus 88 equals 0. Now, you have 12 problems for your homework. You technically could do the quadratic formula for every single one. If you really love the quadratic formula, knock yourself out. Go for it. But I promise you, if you're even halfway comfortable with factoring, it's going to be quicker and easier to factor. So what you're looking for, if you're going to try to factor it, I would recommend just trying to factor the x squareds. If it's bigger than an x squared, a 5x squared, 10x squared, I'd probably just do the quadratic formula. But since this one is already set equal to 0, and it is an x squared, let's at least try to factor it. So, since it's an x squared, I already know how to get the f. 1 times 1 gives me x squared. That's why I say if it's just an x squared, at least try to factor it. You can usually rule it out pretty quickly if you're not going to be able to factor it. Now, if I were to FOIL this out to get the L, I would multiply those two numbers together and I would get negative 88. And then when I do the O and I, those numbers add to give me negative 3. O multiplies to be negative 88. Okay, if I do 11 and 8, since it's a negative 88, one of them has to be negative. It has to be the 11, right? The bigger number, because the 3 is negative. When you add these together, you get negative 3. If you can factor it, go ahead and factor it. And then, since x minus 11 times x plus 8 gives me 0, either x minus 11 equals 0 or x plus 8 equals 0. Add 11, we get x equals 11. Subtract 8, we get x equals negative 8. Okay, what if I have x squared plus 12x equals negative 16? Now, regardless whether you're going to use the quadratic formula or factoring, it has to be set equal to 0. Either way, it has to be set equal to 0. So if you see the problem and it's not set equal to 0, the first thing you need to do is move everything to the same side. So for this one, I would add that 16, and we get x squared plus 12x plus 16 equals 0. Now, kind of like the last one, what I would suggest you do, since it's just an x squared, we could try to factor it, because I do x times x. But to get to 16, I need to multiply to give me 16. Add to give me 12. What are some things that multiply to give me 16? 4 and 4. Now, 4 plus 4 give me 8, not 12. What else? What else multiplies to give me 16? 2 and 8. 2x and 8x can give me 10x. Is there anything else multiplies to give me 16? 16 and 1, which would give me a 17x. Nothing works. I can't factor this one. It's not possible. So check, try, but if you can't factor it, you're going to have to use the quadratic formula. So for the quadratic formula, A would be 1, B would be 12, C would be 16. So if I plug these into my quadratic formula, we're going to start with the opposite of B. So negative 12 plus or minus the square root. Okay, we're going to do B squared. So 12 squared minus 4 times A, which is 1, times C, which is 16, all over 2A, which is 1. Okay, this first step in simplifying is one you need to take kind of slow to make sure you're getting it right. We're going to leave the negative 12 plus or minus the same. Okay, we can take 12 squared, which is 144. Remember, this sign, huge! This is the biggest sign that most people get wrong. Negative 4, 1, and 16. Negative 4, 1, and 16 will give you what kind of answer? That one's going to stay negative. And then 4 times 1 times 16 gives me 64. All over 2 times 1 is 2. Well, the next thing I do, I can subtract these. 144 minus 64 is 80. Now, here's how you know for sure that you couldn't have factored it, because I have an 80 under the radical. And if you try to take the square root of 80, it's not a perfect square, okay? So we're just going to turn it to a decimal so we can estimate. The square root of 80 gives you about 8.94. So we're going to round. So we have negative 12 plus or minus 8.94 over 2. And then to get your two answers, you add, divide by 2, and then subtract and divide by 2. So negative 12 plus 8.94, then divided by 2, use about negative 1.53. Negative 12 minus 8.94, and then that divided by 2 gives you about negative 10.47. So it's nice to check if you can factor, but sometimes it just doesn't work. Okay, let's try 3x squared minus 13x equals negative 4. Now, regardless whether you're going to try to factor it or you're going to try to do the quadratic formula, it has to be set equal to 0. For both of these, it has to be set equal to 0 first. So if I add 4, we get 3x squared minus 13x plus 4. Now, it's just personal preference of mine. You might be able to factor this one. It might be possible to factor this one. But for me, if it has a number in front of the x squared, I am probably going to jump straight to the quadratic formula. I'll show you here once we get through this one how you're going to know if you can factor it or not. So if we do the quadratic formula, a would be 3, b is negative 13, and c is 4. So we would do x equals, this time the opposite of b, the opposite of negative 13 would be a positive 13, plus or minus the square roots. Now be really careful here, because when you take b squared, you are squaring all of b. So if b is negative 13, you are squaring the negative and the 13. You're squaring the sign as well. So it's going to be negative 13 squared minus 4 times a, which is 3, times c, which is 4, all over 2 times a, which is 3. Okay, so if I go through that first step of simplifying, it'd be 13 plus or minus. Now remember, when you do b squared, it does not matter if b is positive or negative, because a positive squared and a negative squared gives you a positive answer. Negative 13 squared gives me 169. Okay, the sign that follows is going to be a negative. And then 4 times 3 times 4 gives me 48. All over 2 times 3 gives me 6. Okay, when I subtract these, 169 minus 48 gives me 121. Here's how you are going to know that you could have factored this. Because I can take the square of 121. That's a perfect square. You get 11. You could have factored this one. And it's kind of a toss-up whether factoring is easier than quadratic formulas. Okay? But since I get 11, it'd be 13 plus or minus 11 over 6. And for your two answers, 13 plus 11 is 24. Divided by 6, you get 4. 13 minus 11 is 2. When you get 2 over 6, it would be best just to reduce this as a fraction, and you get 1/3. Okay, let's do one more. Okay, number 4. X squared minus 9x equals 0. Now, regardless what method you're going to use, it has to be set equal to 0. This one's already set equal to 0 for me. I kind of told you that if it's an x squared, at least try to factor. But remember, factoring, what we usually say is factoring is the opposite of FOILing. And this one's kind of different because I don't have 3 terms, right? The FOIL. I just have 2 terms. And we talked about these whenever we reviewed factoring before the state assessment. Does anybody remember how you factor this one? Now, the airplane method is if it has an AX squared. See how both these have an X in common? Mm-hmm. Yeah, undistributed. Yeah, you're going to use the opposite of the distributive property. Take out an X, and you get X minus 9. Now, you could totally do the quadratic formula for this one. And A would be 1, B would be negative 9, and what would C be? 0. And you could plug those into the quadratic formula. That would totally work, but this is much easier. Because once you take out an X, then you know that either X equals 0 or X minus 9 equals 0. Add 9, so X could be 9.